So we are basically considering what questions under what viscosity of a liquid. Now from our question, we are given at 30 degrees Celsius, we have a viscosity that was given to us to be what 0.02. At 50 degrees Celsius, we have a viscosity that was given to us to be what 0.001, right? Now, what is your question? Your question is simply find the viscosity at 70 what degrees Celsius. Find the viscosity at 70 degrees Celsius. Now, the first thing that should come to your mind is looking at our viscosity that was given to us. We can say this is viscosity 1 and this is viscosity what 2, right? Now, looking at the viscosity given to you, you first identify if that viscosity is a kinematic viscosity or your viscosity is what a dynamic viscosity. Now, I told you how to identify a kinematic viscosity and a dynamic viscosity through their what unit. Now, look at this unit. This unit is actually what Newton seconds per meter square, and this is telling you that you are considering what a dynamic what viscosity. That should be the first thing that should come to your mind. Now, look at the question too. From our question given, the question is simply stating that every increase in temperature, there will be what a reduction in what viscosity. So if your temperature is now increased to 70 degrees Celsius, what will be your viscosity? Now take down the equation for viscosity of a liquid. Now for you to find the viscosity of a liquid, the equation is given to be what U subscript T is equal to what A exponential what B divided by what T. A exponential B divided by what T, where your A and B are constant, so you have to look for what A and B. Your T here is the temperature. Are we together? While U here, U subscript T here simply stands for your what viscosity. Looking at our question, we can see that the question was given to be in two cases. The first case was what at 30 degrees Celsius, while the second case was at what 50 degrees Celsius. Now let's take the first case, case 1. Now for our case 1, we're giving temperature here to be what in 30 degrees Celsius. So what you do is always convert your temperature to Kelvin. So if you are giving in Celsius, convert it to what Kelvin. If you are giving in Fahrenheit, convert it to what Kelvin. Are we together? Now for you to convert 30 degrees Celsius to Kelvin, what you do is you add it with what 273 Kelvin, and that will give you what, if you punch your calculator, you will simply arrive at what 303 Kelvin. So this is the temperature we are to consider for what state 1 or what case 1. Now if we are to consider this for case 1, we have that our U will now be equal to what 0.02 Newton seconds per what meter square. This was what we have here. So what will be your new equation for case 1? Your new equation will now be replicating with what we have here with their certain values. We have our U to be what 0.02, and this will be equal to A is a constant, exponential B is also a constant, and this will be dividing what your temperature, which is what 303 Kelvin. So we can call this what equation 1. Why are we calling this equation 1 is because we have two unknown that we need to what calculate for. Now let's take the case 2. Look at your case 2. Your case 2 was given temperature to be what case 2. You were given temperature in your case 2 to be what 50 degrees Celsius, right? Now what you do is you convert 50 degrees Celsius to what Kelvin by adding with what 273, and that will give you what 323 Kelvin. Confirm your values and drop them on the comment section as well. Now if we've gotten our temperature to be in Kelvin to be what 323, what is now your viscosity? You were given viscosity there to be what? Viscosity for your case 2 was given to be what? 0.01 Newton seconds per what? Meter square. So you input your viscosity here and you tell your examiner that your viscosity was what? 0.001 Newton seconds per what? Meter square. Are we together? So since you were given your viscosity, your case 2 equation will now be what? 0.001, right? And this will be equal to A to be a constant, exponential B to be a constant, divided by your time, your temperature. And what's your temperature here? 323 what Kelvin. Are we together? So we can call this what equation what 2. So what can we see? We can see equation 1 and what equation 2, and that is telling you that we have a simultaneous what equation. So what do you do when you have a simultaneous equation? You simply what solve simultaneously. Are we together? Now we can solve this simultaneously by dividing what equation 1 by what equation 2. Now solving simultaneously, solving equation 1 and 2 simultaneously, you simply have your equation 1. State your equation 1. Your equation 1 will be what? 0.02. So you have 0.02, and this is equal to a exponential b divided by what? What is your temperature for your equation 1? It was what? 303. So we can divide equation 1 by what? Equation 2. And if you do that, we have this dividing what? 0.001. This will also divide what? A exponential what? B divided by what do we have here? 323k. Now remember, what we are doing here is we're solving equation 1 and equation 2 simultaneously by dividing equation 1 by what? 2. That's what we are doing. Now look up. What we can see here, we can see the same constant cancelling out. This can also cancel out. Your exponential cannot cancel out. Reason being that the power here is what? Having a different what? Value for the same what? Parameter. The same parameter, I mean b here. I can see b here, right? But different parameter in the sense that you're having b over 303, and here you're having b divided by what? 323. So they cannot cancel out. But what you can do is you can simplify both powers. Simplifying both powers, what we have here is also written as what? B divided by what? 303, right? Now we can also write this to be what? B multiplied by what? 1 divided by 303, where we look for what is what? 1 divided by 303. And if you punch your calculator, 1 divided by 303, that will simply give you what? 0 point. So you have 0 point what? 00 what? 33. And remember, you can multiply this with your what? B, right? Now do the same thing for your second one. Your second one will now be B divided by what? 323, right? And this will be equal to B times 1 divided by what? 323. Now if you punch your calculator, 1 divided by 323, that will give you what? 0 point what? 0031b, which is your B here. Are we together? Now what do you think you are going to do next? Since you've gotten the values for both your since you've gotten the values for both what? Powers, what you do is you impute them into your given equation. Imputing them into your given equation, you will simply have that this will now be what? What we have here will be 0.2 divided by what? 0.1, and that will give you what? 20. So here you have 20, and 20 is equal to, remember what you are left with here is what? Exponential. The first one is what? 0.0033b, right? Dividing what? Exponential 0.0031b. Now remember, what can you do when you have two exponential dividing each other? Apply the what? The law of what? Logarithm. And from the law of logarithm simply says when you have the same value having what? Different powers, what you do is you subtract their values. So if you have exponential a here dividing what? Exponential b here, what you simply do is you are going to pick one of them, which is exponential, and what will happen to their power? You subtract. So you have a minus b. This is the concept you have to apply here. So if you apply this concept here, what you simply have there will be what? 20, and 20 will be equal to exponential raised to the power of what? 0.0033 minus 0.0031, and this will be in what? B. Remember, our B is outside. Are we together? Now if you do that, you will simply have 0.0033 minus 0.00131. What I have on my calculator is simply what? 0.002. So this will be 20, and this will be equal to exponential. When you punch this on your calculator, may arrive at 0.0002. and we have our b here. Are we together? Now, what are you seeing? You are seeing one side of your equation having an exponential, and the second side of your equation is not having what? An exponential. But look up, we want to cancel out this exponential, so we'll get the value for what? B. That's our interest. So now, what do you think you are going to do to remove what? Exponential. Remember, when we are talking about integrating factor, the step 4 of integrating factor is when you have an exponential raised to the power of any value, what you do is you apply ln to that exponential such that your ln will cancel what? Exponential. Now in this case, we are going to apply what? Ln to both sides of the equation. Applying what? Ln to both sides of your equation, to both sides. So if you apply ln to both sides, you simply have ln 20 here will be equal to what? Ln exponential 0.0002b. Are we together? Such that your ln can cancel out exponential, and you simply have ln what? 20, and this will be equal to what? 0.0002b. Are we together? Now what do? You punch your calculator. What's ln b in your calculator? Ln b will simply give you what? 2.99 what? 5. The next value is more than 5, so you approximate. So it's giving me what? 2.996, and this will be equal to what? 0.0002. Are we together? So we have 0.0002b. What do you do to get b? To get b, you divide both sides of the equation with what? 0.002. We are dividing here with 0.002, and we are dividing this side with what? 0.002, such that you are now left with your b to be equal to what? This is cancelling out, so your b will now be equal to, what you do is you punch your calculator. What you have here dividing what you have here, what will you arrive at? And that will give us our b constant to be what? 14950. Is that what you have? If that's what you have, drop a thumbs up on the comment section. So what I have here is what? My b is simply what? 14980. So have 14980. If you have the same value, drop a thumbs up on the comment section. Thank you very much. Now remember, we've calculated for just one constant, which is b. What do you think we are going to do to calculate for your constant a? Remember, you can call this equation 3. Why are we calling this equation 3? Because we can still substitute this value into any of the equation 1 or what? Equation 2 to get what is a. Now, since we've called this equation 3, let's substitute this into equation 1. So substituting that, substitute into equation what? Equation 1. And what's our equation 1? Our equation 1 was given to be what? 0.02 is equal to what? A exponential b divided by what? 303. That was our equation 1. Let's confirm that. Equation 1 was 0.02 a exponential b divided by 303k, right? And that's what we have here. So since we've gotten what is b, we just impute the b to this equation, and we are going to get what is a, right? How do we do that? So this will be what? 0.02, and this will be equal to, we don't know what's a, right? Exponential raised to the power of, what's your b? Your b was calculated, and we call b equation 3 to be what? 14980. So we have this to be what? 14980 divided by what? 303. So what you simply do is, we have an exponential raised to the power of this, and we want to get what is a. You divide both sides by what? Exponential 14980 dividing what? 303. You divide here by what? Exponential 14980 dividing what? 303. And what will you arrive at? This is already cancelling out. You are left with your a value to be equal to. So you can punch this directly in your calculator. From what I punched from my calculator, I had what? 6.760. So what I have here is what? 6.7604 times what? 10 raised to the power of what? Minus 24. So this is my constant for my value for what? A. So we've succeeded in getting both constant for what? A and b. Are we together? Now remember, what was your question? your question was given to be what? At 70 degrees Celsius, what is now your viscosity? At 70 degrees Celsius, what is now your viscosity? Are we together? So what is the expression we are going to derive from our given equation? The expression you are going to derive will simply be what? Remember, u of t was equal to, right? So we have u of t was equal to a exponential bt. Are we together? Now, what is now your a? We already have the value for a to be what? 6.7604 times 10 raised to the power of what? Minus 24, right? Exponential raised to the power of what is now your b? We calculated b to be 14980. So you have 14980 divided by what? Your time, which was given, your temperature, which was given to be what? T, right? And T there is what? 70 what? Degrees Celsius. So this will be the expression from your given what? Question. Remember, why are we putting T here? We don't know the value for our given what? Viscosity. That's why we put T here to be just T. Sometimes you can still put your T here to be 70 degree, right? So what you do is you convert 70 degree to what? Celsius. Now let's convert 70 degree to Kelvin. So you convert 70 degrees Celsius to Kelvin, and that will be what? 70 plus what? 273. Now what's 70 plus 273? 70 plus 273, that will give you what? 343. So this is 343 Kelvin. So you impute your 343 Kelvin here. So you have 3 what? 43 Kelvin. Are we together? So this will actually be the expression from our given question. But remember, what were you asked? You were asked to find the viscosity at 70 what? Degrees Celsius. That was what we were asked. Now at 70 degrees Celsius, what do you think we are going to do to find your viscosity? Now we've already imputed what? 70 degrees Celsius here, and we said 70 degrees Celsius is what? 343 Kelvin. So what you do is you impute the value for your given temperature here, which is what? 343, and you punch your calculator to get a certain value for your what? Viscosity. Now looking at from what we have here, we can see that u of t here, u of t, if you punch this directly in your calculator, you simply have u subscript t to be what? 6.27 times 10 raised to the power of what? 17 Newton seconds per meter squared.